Hello guys and girls, I'm glad that you've decided to watch the video. Hopefully you will make it to the end. So this lab that we're doing is just kind of to get us ready for the school year. So this first page is just telling you what's going to be required of you from watching the video. So the first thing that you're going to do is get out a piece of paper, and as the video goes on you're going to need to copy down the title, the purpose, the materials that are listed, and then you're going to have to come up with a data table. So all of that will be complete when you walk into class, and you will get that information from the video. It says get enough information from the video that you can answer 3 or 4 questions about the lab/video, so I know that you watched it. You're going to take that quiz at the end of watching the video. You're going to use a website or an app that you can put on your phone or iPad, a smartphone, called Socrative, and you're going to take the student version. It says be prepared to step into class and begin the lab with minimal questions. So the idea here is we're saving some class time by you watching this video at home, and you can step in, start the lab, and then we can hopefully finish the lab and move on, instead of wasting some class time going over some things that are hopefully pretty simple. So questions, of course, during class are more than welcome, but hopefully they're not questions that you've learned throughout this video, and as the school year goes you won't be allowed to ask questions that have already been answered in the video. So to be clear, right, tomorrow when you show up for class you need to have your lab report started with your title, purpose, material, and a data table constructed and labeled. You will have any notes that you can refer back to. It doesn't have to be formal, just jot them down somewhere, scrap sheet of paper, that you can look back and see how to complete the data analysis section. And you're going to need to complete the data analysis section just through creating a graph in a program that will be shown in the video, and you'll have access to at school. So you'll also have to have already taken the short pre-lab quiz, and then it says down at the bottom you can download the app either on an any smartphone, doesn't matter which one you have. Look for the Socrative app, and it is you want the student version, not the teacher version. If you don't have a smartphone, just use a computer and go to the website listed there, enter room 88083, and then it'll take you to the quiz. It says it's it's going to be what's your name, what's your class period, and then ask you a couple questions about the video. Okay, let's get started. So this lab is just an introduction to the types of labs we're going to do here in physics. It's not a physics lab, obviously, if it's the circumference versus diameter of a lab, the circumference versus diameter lab. So it's just to get you used to the style of labs and kind of the process that we're going to go through. So the purpose of this lab is to determine the relationship between the circumference and diameter of a circle. Some of you are already going to know this relationship, or you could probably use it, look it up, very simple. But if this was an actual physics lab, you wouldn't know the relationship, and really when I say determine the relationship, we're really looking for a mathematical relationship between the circumference and diameter. So make sure you copy that down. What you're going to have at your disposal, you are going to have a meter stick or a ruler depending on the length of the object you need to measure. You're going to have a string, and you're going to have circles of various sizes, which I'm going to give you a picture of kind of what you're looking at here. So in the lab, a lot of times we'll discuss, well, what kind of measurements do we need to take? What kind of things do we need to record so that we can then later use it in the data analysis section? So in this case, I think it's pretty straightforward. If we want to determine the relationship between circumference and diameter, well, you're probably going to record the circumference and the diameter of a bunch of different circles from the ones that are supplied that you saw in the picture. So how many different circles should we use? Part of your grade on the lab reports, when possible, and this one is one of those situations. It'll be based off the accuracy of your results. So you're going to want to have accurate measurements and an accurate graph that will produce accurate results so that your percent error is going to be low. So consider that when you want to figure out how many circles you're going to use. And your lab group can decide. It's up to you guys. I would use a variety from small to large circles, and then I would pick a decent quantity, but not overkill where you just have so many circles. It's ridiculous. You know, people are done with their lab and you're still measuring circumferences and diameters because you've got too many. But that's something you guys are going to have to discuss tomorrow. So when you record data, you should record it in a table. Don't list it out. Don't jot it down. Put it in a data table. So a data table, well, I think you guys know what a table looks like. It's got lines and it's got little boxes in there for you to record stuff. Now, under the data section, you're never going to put anything that you calculate. It's only going to be measured values. So if the only thing you have to measure with is a meter stick, ruler, and string, you're only going to record numbers that you got from these devices. You're not going to record any averages or anything like that. So you guys need to make this data table, and that also should be made before you come into class. So once you get all of your data, and your group takes all those measurements, you then move on to the section of data analysis in your lab report. And in here, this is where you're going to crunch numbers or graph numbers or calculate averages, things like that. So next section, right after you make your data table, data analysis, right? This is the only section that you're going to have those calculated values, graphs, and so on. And basically what's going to happen for most of the labs, you are going to create graphs. From those graphs, you're going to figure out the relationships between your two variables, which in this case is circumference and diameter, and then from the graph we're going to write an equation, which is really easy. You probably learned how to do it in Algebra 1-2. So it says normally in a lab for this class you would have to find the average of collected data or use the data to make a calculation. In this lab you don't have to do that, so you're not going to have to worry about it. But if you had to do averages, it needs to be under data analysis, not data. So the first step, you are going to use a program Logger Pro. So someone's going to have to log into the computer, doesn't matter who, someone in your group, and then you're going to have to open up Logger Pro and you are going to create a graph. Okay, and these are the types of things that you're going to have to remember. Circumference goes on the y-axis, diameter is on the x-axis. Please, in the data table and on the graphs, always put your unit of measurement on your numbers. If you tell me a number is 13.2 and you don't tell me what it's measured in, I'm going to assume it's 13.2 bananas. And 13.2 bananas has nothing to do with circumference and diameter. So you have to put units on every single number. The program that you're going to be using is called Logger Pro. It's made by Vernier. It might be called Data Analysis depending on your computer. So once you log in, go under the Start menu, find out, get to all these folders. It's not going to say Data Studio. You need to find the folder that says Vernier Software and then click on the program Logger Pro to open that up. It's a very user-friendly program. Once you have it open, you're going to use this to graph your data, which is very simple, right? You've got your table that you can click on, and then you can go through and graph all your data. So we have this data, and you can see it's down here at the very bottom left-hand corner with these little red lines. It's not very visible. It's we're using generic X and Y, so there's some things we want to do to make our data a little bit more meaningful. First, we're going to give it labels. So on the X-axis, if you double-click where this X is, it brings up this window, and now you can name it. Let's say I was graphing pressure. So I can go through and, okay, a short name would be a capital P. The units for pressure is pascals. On the Y, if I want to change that, let's say I was graphing volume. Oops. And that would be in milliliters. So you can see on the data table and the graph, it changes it in both places. Now, we're not able to see much of this data because our graph is so big. When you move your cursor around, when it turns into this arrow, I can move the graph kind of into different locations so I can see it, but it's still not very big. You can choose to make it larger a couple different ways. You can hit this button, it'll auto scale in to your graph data. The only drawback to this is that now I cannot see my data point 0, 0, and I always want to have that visible on the graph. So what I want you to do is, if you choose to use that button, go through and still show my data point 0, 0 here in the graph. Now the other thing, I have a line that's connecting my graph. I don't want all of that. So while these boxes right here signify that I'm on my graph, not on my data table, right? The boxes are now on the data table. So I'm on the graph. I'm going to go under Options, Graph Options, and I'm going to get rid of the connecting points, and instead I'm going to put on these point protectors. So now I'm left with just my data points. And now I want to look at this trend and see, okay, well, what does it look like? Well, it looks like a linear line. So I'm going to go up to here where it says linear fit, click the button, and now this gives me the line of best fit. So you can see now in my equation I have V equals M, right, my slope, which is 2, times P, which is my x-axis, plus B, and my B in this case is 0. So the program's kind of nice because when you enter in your data set, it helps you out with the units. So I know that the units of my slope is milliliters over Pascal, and my y-intercept is milliliters. The correlation is just a number that tells you how your data is compared to your fit. So we chose a linear fit. The correlation is 1. That's the best correlation, a 1 or a -1. So I know my data is very close to being linear, or in this case it's perfectly linear. From here you can take a screenshot and put it into a Word document. You can print it out in the printer in my class, and you can cut and paste it into your lab report, whatever works best for you. I prefer for you guys to cut and paste it into, use the button on your keyboard that says print screen, and then put it into a Word document and email it to yourself so you can actually insert it into the lab. But this lab's going to be written out on paper, so it's fine to just print it out in the printer in class. Your second step, once you have a graph, hopefully it's going to come out to be kind of linear. It's not going to be any sort of parabola or hyperbola or anything like that. So hopefully the graph is a straight line. And think back to Algebra 1-2 and Algebra 3-4. What simple equation do you use to write out and represent the data in that linear line? And that's something your group will have to talk about. It's a pretty easy thing, and there's one of those, if you guys talk about it and can't figure it out, that's absolutely something that you can ask me, and I'll try to give you some more hints. So once you graph your data, you're going to then take that linear line, write out an equation using the data from your graph, the line of best fit from your graph. And then what will happen is once you guys get that equation, I will ask you to write it on the smartboard, and we'll talk about not using y and x and using some other different symbols or different letters to represent our variables instead of just the generic y and x. And we'll talk about units. And that's about it. So those are the steps you need to get to and be able to work through. Of course, ask questions, and I will definitely be there to answer them.